either, so kind of a win.
With matching pants. And shoes. Oh my god.
So we are on Law of Cosines today. Are we ready? So here's the deal. Why do we have Law of Cosines? Why do we have Law of Sines and Law of Cosines? Really is probably the better question. So remember, obviously, not every triangle is a right triangle. That's why we have these other Law of Sines, Law of Cosines. Now, Law of Sines is great when you have an angle in the opposite side. That's what we need to set up our proportions. However, that's not always the case. What if I just give you three sides and no angles? You could not use Law of Sines. So that's where Law of Cosines comes into play. So it just depends on what given information you have as to which law you're going to use. Now, if we're going to be honest, Law of Sines is the easier of the two. It's just less computation. I do like it for that reason, but you need an angle and opposite side. We're not going to always have that today. We are going to do a couple word problems today. We're going to talk about headings and bearings, basically like you're going north, west, south, east, some directions. And then I kind of alluded to, there's that Huron's area formula that's going to be on the formula sheet you'll be provided. Just, it's another formula to calculate area of a triangle that you probably have not seen yet. Now, like I said, or like you saw, you will not have to have Law of Cosines memorized. You will be provided the formulas. You just have to know how to use them. But I don't really think they're that hard to memorize because, of course, math's all about patterns. So notice, whatever side you start with, like here you're starting with A, I just said, okay, I square the other sides and add them, minus 2 times the product of those sides, and then the cosine of the angle across from the side you started with. It's always that pattern. So I'm not standing up here like, ooh, am I using A squared formula, the B squared? I don't care. I just start with the side and I end with the angle across from it. And it's always, of course, the pattern. Square the other sides, minus 2 times those sides. I don't need to memorize the formula, but you will be given those. Okay, so tunnel is to be built through a mountain to estimate the length of the tunnel. Surveyor makes the measurements shown in figure 3, which is to the right there. Use the surveyor's data to approximate the length of the tunnel. Now, you were finding, I know they don't copy the best sometimes the pictures, the length of the tunnel from A across to B. Now, just for dramatic emphasis, I want the side across from angle C, so I'm going to label it little c. That's a very tiny little c up there. That's what I'm trying to find. Now, I could not use Law of Sines if I had a choice because I do not have an angle in opposite side to start with. So I'm going to use Law of Sines. I need to find c squared. So clearly, I mean, just to show you, we're using this third equation, but I don't like to memorize formulas, patterns. I square and add up the other 2 sides. I don't care if you start with the 388 or the 212. 388 plus 212 squared minus 2 times those sides. So 2 times 388 times 212 times the cosine, Law of Cosines, cosine of the angle across the side you started with. So angle C, which is the 82.4 degrees. Now, I hear some of you typing in your calculator, which is fine. You can type this in your calculator and get the answer, though, in one step. Because to get rid of the squaring, you need a what? What cancels squaring? So I just hit the square root key first, and I just type in all of that crud on the right-hand side in one step, and it will crank out the answer. Let me give you a second, friends. Okay, sides of the triangle, or find the angles. Okay, so again, I just feel like I have to give this spiel. I could not use Law of Sines even if I wanted to. You have to have an angle in the opposite sides. We're trying to find it. Now, don't get ahead of me though, because there is one little trick on this. Now, we talk a lot about our triangles staying proportional, meaning across from the biggest side, biggest angle. Smallest side, smallest angle. You get the pattern. Well, once in a blue moon, if you don't do this very rarely does it happen, but I've seen it happen. If you don't work on this in order from biggest to smallest, sometimes your triangle doesn't turn out proportional. Very rarely does it happen. 98% of the time it's not an issue, but I'm like, oh man, okay. So 12 is the biggest side. So I'm going to find the biggest angle first because I want to ensure that it is going to stay in proportional. So I'm going to just make sure so I don't have to worry about it. I'm going to work biggest to smallest. That is my pro tip. And like I said, 98% of the time it really doesn't matter, but I have once in a blue moon seen it. where your triangle turns out not in proportion if you don't work in that order. All right, so I'm going to find angle C first. So here we go. C squared equals the other two sides squared. I'm going to do 5 plus 8 minus 2 times those sides times the cos of the angle across from the side we started with, which is, of course, C. Now, I can do a lot of this work in my calculator too. So let's pull up my calculator. So I know I am trying to get this cos of C alone. I don't expect you to write all this computation, but just to get it started. So I know I need to subtract off 5 squared, and I need to subtract 8 squared. I know I need to get rid of those. So I'm just going to type that in my calculator as it is. I'm going to do the 12 squared. I know it's 144. We can make it 144, but let's make it easy. Minus 5 squared minus 8 squared. So I've got 55 over there. And then I'm going to do this part. I still have this. I can do some of this in my head. What's 2 times 5? 2 times 5, 10. 10 times 8, 80. Okay, to solve for cos of C, I'm going to divide off negative 80. And you know this, to get the angle in your calculator, you're going to hit second cos. Okay, so really I can do this all in my calculator. I'm going to do second cos. I got to look, I forgot what it was. 55 over 80. Okay, negative 55 over 80. Okay. And I don't care, everything's a whole number, let's round to a whole number. And again, on your test Friday, it's going to tell you angles to the whole unit, sides to the tenth. So that's how I'm going to roll. I'm going to go 133 degrees on it. So easy setup, I think. Any questions on the calculations? Again, I don't care if you actually write that you're subtracting those off. You can do it all in the calculator. Now, here's the nice thing. I'm going to label it in the picture because I just like it to look pretty. I could do some more law of, some more law of cosines on it to get the other 2 angles. I could set up very similar equations. Or you do have an angle on opposite side, you could use law of sines. Does it matter? What do you think's easier? Sines? Okay, let's do sines. So I'm going to do sine of my angle, my 133, over its opposite side. Now, remember, we want to work in a specific order to make sure the triangle stays proportionate. I want to work biggest to smallest. So I'm like, okay, 8's the next guy. So I'm going to do sine of B over 8. And again, you could have done law of cosines on it. It doesn't matter. You'll get the same answer. Figure out what B is. Round to the whole. I did them all to the whole. Feel like I should have some Jeopardy music playing. All right, what do you got for B? Starts with a 2.
2, 9.
Thank you, Kale. You should get 29 degrees. And I like to label in the picture. I like to do it. And then, of course, don't sweat it. Get your angle C super easy. All 3 angles better add up to what? All 3 angles add up to, what do you say? 180. What's your angle A? It's small. 18, I heard it. Okay, so before we go to the next one, easy, but I got to point some things out, of course. First question for you. Anybody need me to type in the blue part to show you how to get angle B? Next question. Double check my triangle. Is it in proportion? Biggest angle, biggest side. Medium angle, medium side. Smallest angle, smallest side. Is it in proportion? It is. We're crushing it. Now, last thing. So I did use law of sines, okay, which is fine on this one. I might question it on the next one if you're working ahead of me, because I'm like, oh, okay. Remember, we have that weirdo ambiguous case on law of sines. If the opposite side is smaller than the adjacents, you could have 2 triangles. I didn't sweat it on this one because my opposite side, the 12, is bigger than the other 2, so I didn't worry about the 2 triangles. So that's the only downfall. If you want to switch into using law of sines, you might have to worry about the ambiguous case. It wouldn't matter here because my opposite side was bigger. So it was not going to be a two triangles. We didn't talk about it, but it is something I had in the back of my head. Okay. All right, solve triangle ABC. Well, you know I like a picture, so I'm going to draw the triangle. I don't know why, I just like to draw it and label it and look at it and make sure it's all in proportion. I don't know if it's a cube or obtuse, so I'm just winging it here. I'm going to think a cube for right now. We'll see what we get. 46.5 for A, side B, got it, side C. All right, so I need side A, and of course those other two angles. So first question for you, as you get your triangle drawn, can I use law of sines to start? Do you know an angle and opposite side? So we're going to have to use cosines. So here we go. I'm going to, of course, find my third side here. So I'm using that first formula. But again, you know I don't like to memorize formulas, pattern. I'm going to square the other sides and add them together. Doesn't matter which you start with. I could have that switched, who cares? Minus 2 times 10.5 times 18 times the cos of the angle across the side we started with, which is angle A, the 46.5. And again, we can type this all in our calculator in one fell swoop to get the answer, because we know to get A alone, I need to cancel the squaring with a root. All right, type. What do you need me to type that in the calculator? It's literally what's in front of you is how I typed it in. There is nothing magical about it. Now, you know I like to label on the picture. Okay, so here's the question for the day. Do you want to switch into law of sines? I'm a little sketch on it. I'm questioning it because I'm like, oh yeah. I'm thinking, yeah, let's use law of sines. I have an angle in the opposite side. But I'm like, oh man, this opposite side is smaller than 18. It could lend itself to getting into that weirdo ambiguous case. Maybe it won't be a problem. Maybe it will. But if I want to make sure that it is not, of course I could just go ahead and use law of cosines and I don't even have to worry about it. So I'm going to use law of cosines because I don't want to have to get into an ambiguous case if I don't have to. Doesn't matter which angle we find. We need B and C, so I'm just going to pick one. I don't know, I'm going to be lame and go alphabetical order. I'm going to find angle B next. Then clearly I can do C because it'll all add to 180. Okay, so I'm going to start with the side across from it, 10.5 squared. I'm going to add up my other two sides squared, the 18, the 13.2 squared, 2 times those sides, times the cos of the angle across the side we started with, which is angle B. So a little more time consuming, but it might pay off in the end because we don't have to stress about the ambiguous case. Now, of course, a lot of calculating. So in my calculator, I'm trying to get cos of B alone. I just subtract these off and let my calculator do the work. So I am going to pull up the calculator here just for, to show you, of course. I have faith that we can type those in, but just to show you, let me grab mine too. Because my calculator always covers up the numbers. So I'm going to type in the 10.5 squared minus 18 squared minus the 13.2 squared. Got it. So I'm going to jot that down, negative 387.99. And then I'm going to type in this part, because I don't know what I know 2 times 18, but I don't know times 13.2. Negative 2 times 18 times the 13.2. Got it, negative 475.2. Cos of B. And then, of course, I know you know, divide this off and hit your second cos. Oh, man. I can't write and talk. 475.2. Okay, punch it in. Second cos. What do you have for angle B? 35 point. I'm just going to go, well, no, they're to the 10th. Let's go to the 10th. 35.3. And then, of course, very easily, you found angle C. They all should add up to 180. So what's angle C? 98.2. Got it. So again, you could have, I know law of cosines is more time consuming. My question on this one, on law signs, why I kind of was like, I don't know if I want to use law signs, because my opposite side was smaller than the 18. So I was like, that could potentially lead you into that weird ambiguous case. I didn't worry about it on the previous triangle because my opposite side was the biggest side. No ambiguous worries. So that's the only glitch, I should say, that you kind of have to be a little conscientious of this. All right, last thing, more triangles. The area thing's really easy at the end. Last thing we got to kind of talk about, navigation, because you're going to have obviously some word problems, and they are going to talk about directions. Now, I know you know the compass rose, north, south, west, east, obviously. We're always starting from the origin, 0, 0. So if they tell you a plane goes north, east, obviously you're in quadrant 1. North, west, quadrant 2. If you were going southwest, 3. Southeast, 4. And notice the angles always are made with that north-south line. So just keep that in the back of your head. It's very simple, I promise, when we draw these pictures, but we have to be conscientious of the direction. So ship A, I'm not drawing a lighthouse, kids, it's not going to happen. It's 72 miles from a lighthouse on the shore. Its bearing, direction, from the lighthouse is north 15 degrees east. Ship B, I feel like I'm saying bad words when I say ship, but anyway, ship B is 81 miles from the same lighthouse. Its bearing is north 52 degrees east. Find the number of miles. Okay, blah, blah, blah. So first thing I'm going to do is just draw my compass rose. North, south, west, east. Just get your graph grid going here. North, south, west, east. Now, we always graph anything. We always start, of course, from the origin. So this is where your lighthouse is. You like that picture? That's all I got in me today, lighthouse. Okay, so ship A is 72 miles, okay, bearing north 15 degrees east. So it's going north, 15 degrees is teeny tiny, not drawing the scale, right? 15 degrees east. So ship A is out here, and this is your 15-degree angle. Is that little teeny tiny baby one. I will label how far it is out there in a minute. But let's do ship B is 81 from the same lighthouse. Its bearing is north 52, bigger angle, north 52 east. I'm like, okay, I got it. North 52 degrees. I'm going to say he's out here. So from here over is 52 degrees. And we want to figure out how far apart are these very lovely ships. So I'm going to connect my triangle, label that side X. That's what I'm trying to find. Now, don't forget too, you do have some sides on the triangle because they give you the distances. Ship A is 72 miles out. So the length of this red side is 72. I'm going to try to sneak it in here. And it tells you ship B is 81 miles out. So you do have the two sides. The key is we need this angle right here. Well, we can handle it because we love geometry. We crush geometry. If this little outside angle is 15 and the whole thing's 52, what's this little inside one? How are you going to find it? Subtract. 52 minus 15 is 37. Or, I can't help myself, the love of geometry. I'm really thinking about angle addition postulate. Yeah, the two angles add up to the big one. Okay, that's fun. I like the looks on your faces. Okay, next question. Can you use law of sines or do you have to go cosines? Cosines. We don't have an angle on opposite side. I'm going to find this side x. I'm not going to think about which formula. I just know the pattern. I'm going to add the other two sides up squared. Minus 2 times the sides times the cos of the angle across from the side we started with, which was that very lovely 37. And I know you know to get rid of squaring, we root it. And we can type that in our calculator in one fell swoop. Since the other sides were to the whole, I rounded to the whole. You can go to the 10. I'm not, if it doesn't say, I don't get in a twist over rounding. Least of my worries. All right. No, I'm kidding. All right, what do we have for the distance between the ships? 49.3 you should get.
49.291.
Okay, all right, let's just go 49.3. Any questions on typing it in? All right, last thing I have for you is the easiest thing of the day. Are we ready for Huron's? It sounds fancy. Huron's area formula. Now, we've kind of talked about some area of triangles. We know our old school, middle school geometry formula, half base height. Okay, sometimes, of course, you don't always have the height. You don't have that right angle. So I showed you the one formula that had signs in it. Half times the side times the side times the sine of the included angle. God, it's like geometry here. Obviously, you don't always have an angle. So you might just have three sides on the triangle. Well, old school, I'd have to draw in the perpendicular height. I'd have to try to use SOHCAHTOA or some random thing to find it so I could use my formula. This is a whole lot easier. First thing you're going to do is calculate S, what's called the semi-perimeter. Perimeter. You add up all three sides, and then you're going to do half of it. Semi, half, semicircle, half a circle, half of it. So total the sides divide by 2. Piece of cake. Then you just have to use this formula. It's the semi-perimeter minus the first side, minus the second, minus the third. And you can literally do most of the work in your calculator. So here we go. This is buys a triangular lot, yada yada. Lot frontages on the three sides. You can see them, 125, 280, 315. Find the area. Old school, I'd be trying to draw the height in, using some SOHCAHTOA. It'd be really time consuming. This is easy. I'm going to do my semi-perimeter first. So I'm going to add up all the sides. That's the perimeter part. Doesn't matter what order you add in, just add them. And then the semi, divide it by 2. Or half of it is the technical. So first calculate that for me. What is your semi-perimeter? This is definitely not a chapter that lends itself to a no calculator quiz, is it? So you should get 360 for the semi-perimeter. Now, for the final area answer, and really, from here you can mostly type it in your calculator, but I'm going to set it up for us, obviously. It is your semi-perimeter, and then the semi-perimeter minus a side, and you can just type that in. You don't have to mentally subtract it unless you want to. Semi-perimeter minus the second side, and then the semi-perimeter minus the third side. And I just type in what's in green and make it easy. Avery, what'd you round to?
The whole number.
Oh, I went to the top this time. Interesting.
Back to the million. Wait, how far did it go?
I do enjoy sometimes when I don't tell you what to round to and you guys will give me like 8 decimal places. All right, you get something kind of big, which area answers are kind of big.
17,000.
You got it. 17,451.
What? Round up.
0.6. Let's throw a label on it. We're in feet, so I'm going to say feet squared.
10,000. Get 20,000.
Okay. So any questions typing that in the calculator?
About 7,000.
So much calculator work, my friends. So much calculator work.